Oh man, I know you guys are super pumped up to solve this rectangle problem. Which do you see what it spells? It's a rectangle goat. I love to make my quadrilaterals and triangles spell nifty things. So this is rectangle goat, which is pretty cool. Alright, so it says find the length of each diagonal in the rectangle, which g to the a is 2x plus 15. And I'm going to label that in my picture, you guys, because that's going to help me when I solve. It's always helpful to label your picture in geometry. So I know that g to the a, so this diagonal is going to be 2x plus 15, the whole thing. So I have to remember that. 2x plus 15. And it also says that t to the o, so segment TO equals 5x minus 12. So I'm going to write that right here, 5x minus 12. Alright, so using our nifty properties of rectangles, we have to conquer this problem and find the length of each diagonal. So eventually we want to find GA and TO. Alright, so here are properties of a rectangle, which, since it's a special kind of parallelogram, it contains all the properties of a parallelogram. By the definition of a rectangle, it has 4 right angles. Alright, and then the last property are the entire diagonals are congruent, and actually, since it is a parallelogram, we know the diagonals bisect each other, so each little piece of the diagonal is also congruent. Alright, so we know things about the diagonals. So do you see a nifty property over here that pertains to the diagonals that just might help us solve the problem? You guys got it. It is congruent diagonals. So if my diagonals are congruent, how can I set up this problem? Holy hot dog. You guys are like the smartest people I've ever taught in my life. If they're congruent, you do set them equal to each other. So I'm going to set these bad boys equal to each other and find the value of x, which will then help me find the length of each diagonal a little bit later. So if you guys think you understand how to solve the problem from this point, I highly encourage you try it on your own and see if you get it right in the end. Okay, so I'm going to set these two bad boys equal to each other. So 2x plus 15 will equal 5x minus 12. Alright guys, let's start solving this thing for x. So the first thing, we need to bring our x's together because they're besties and they need to be together. Okay, so I'm going to bring my 2x to this side. It really doesn't matter, but it's good to try to keep things positive, which if I bring a 2x over, it will leave things positive. Okay, so how do we move a 2x to the other side? Absolutely, we do subtract it on both sides. Which 2x minus 2x cancels and turns to 0, and 5x minus 2x gives me a 3x. So now what I have is 15 equals 3x minus 12. So now I gotta get this x by itself. So I need to bring this negative 12 to the other side. It's irking me. So how do we bring it to the other side? You guys are too cool for school. You do add it on both sides. Alright, since it's the opposite of a negative. So negative 12 plus 12 cancels out and turns to 0. And 15 plus 12 gives me a 27. Alright, so now we have 3x equals 27, which I'm going to bring this over here because I'm running out of space. Sorry, you guys. So, and I'm going to flip-flop this. So we're going to have 3x equals our 27. I cannot write. That does not look like a 2. Sorry, guys. That's like a seriously wonky 2 right there. Alright, so this 2... sorry. Always have your whiteout handy just in case something like that happens. Demon Cat's got me, you guys. Sorry. Alright, so now I need to get x by itself, which the 3 is secretly multiplying to my x. So the way I move that bad boy to the other side is by dividing the 3 on both sides. Which 3 divided by 3 cancels and turns to 1. And 27 divided by 3 equals a 9. Okay, so this went over here. Sorry about that. Alright, but we are not done. Remember, in geometry, you are not necessarily done after you find the x. It says find the length of each diagonal. Okay, so we need to find the length of GA and TO, which now that we have X, we can conquer the diagonals and figure out what those bad boys will equal, which I'm going to do that over here. So we're going to start with GA, which equals 2x plus 15. And if we do it correctly, since our diagonals are congruent, this one's congruent to this one, we should get the same thing. Okay, so this whole diagonal is the same thing as that one. So if we did it correctly, we will get the same thing. So let's see what happens. So we have GA, and eventually we're going to solve for T to the O. Alright, so everywhere I spot an X, I'm going to replace it with my 9, and that will help me to find my diagonal. Okay, so GA equals 2 times an X, which X is 9, so I'm going to replace that bad boy with a 9, plus 15. So 2 times 9 gives me 18. And 18 plus 15, that is going to give me 33. So GA is 33. Yay! We have found one of our diagonals. So GA is 33. So if we did this correctly, TO should also be the same thing, which is 33. So let's see if we did it right, you guys. So everywhere I spot an X in the problem, I'm going to replace that bad boy with a 9. Alright, so T to the O equals 5 times the X. Holy hot dog. So times 9. And then we're going to subtract that bad boy by a 12. Alright, so 5 times 9 gives me 45. And 45 minus 12 gives me, say what, a 33. Yay, we got the right answer. So T to the O equals 33 as well. Yay! Oh, I'm messing up my colors. I like to be color coordinated. Oh no, you guys. So 33, and then I'm going to box it in blue because I like to make my work colorful and pretty. Math is a very pretty subject, so you need to jazz it up and make it look pretty. Oh man, you guys. So now the finale will be about a square. So I know we've had so much fun solving things about a rhombus and solving things about a rectangle, but now get ready for the square.